Hello and welcome to another edition of Meet the Pros. I'm Tony Donovan, Product Marketing Rep for Hydraulic Mining Shovels, and I'm here today with Kent Clifton, our Senior Application Consultant in the Global Mining Division. We're here today to talk to you about loading tool selection and some of the factors and considerations you need to go through and understand before making a recommendation to a customer. So with that, I guess, Kent, really the first thing we want to make a point of is Caterpillar's in a unique position because we are the only OEM in the industry that can offer all three types of loading tools, which are electric rope shovels, hydraulic mining shovels, and large wheel loaders.
Correct. And you look at these machines, they can all deliver a different cost per ton, but there's definitely applications that some are better suited. And when we start looking at cost per ton, there's a lot of things that we have to consider when we look at that as well.
So really, we're looking at the application to dictate what is best for that given mine site. With that, let's go through some of those mine site factors, and maybe we want to start here with electrified versus non-electrified mines.
Right, and you can look at electrified and non-electrified, and even today we have some options available that if your mine plan would call for a rope shovel, long mine life, we do have options today that will allow us to bring in that rope shovel without having power supply from the grid. So we can bring in Cat generators with the onboard system that we have available today to allow us to run that rope shovel without the power from the grid.
And we also offer electric hydraulic mining shovels, so if you do have electrical infrastructure, that's an option as well. But then talking non-electrified, without the power generation on an electric rope shovel, then you're really looking at the diesel-powered hydraulic mining shovels and large wheel loaders.
Exactly, and then even with those machines, we have to look at the environment that they're going to be running in, and even in some instances, mine plan, underfoot conditions, to really get a clear understanding of what's going to be required for the mine, because each one of them will have different parameters that they perform better in.
Why don't we talk a little bit about floor conditions and what are some of the things that you look for in the floor conditions that kind of dictate which of these machines would be better in a given application?
Right. So you look at a dry, hard floor. Obviously, that's conditions that a wheel loader likes very well. You don't have high rolling resistance. It's very firm. Remember that your wheel loader is going to have a lot higher PSI with rubber than you will on tracks. One of the advantages to a track machine on soft underfoot conditions is that you can get wider pads, which is going to give you a lower PSI, so you start getting into very soft conditions where rolling resistance will be high for the wheel loader. The hydraulic machine can definitely perform better there. And even in some instances, the rope shovel, we have adjustments or different sizes of pads that we can put on to allow that machine to even float greater than what you would get with a wheel loader.
Let's move to fragmentation, blasting techniques, and just general digging conditions. What kind of factors does that play into the selection process?
Well, you get to some environments, some areas, just think of some of the areas that are very close to small towns and cities in Australia where you can't blast. So then you look at the difference between a hydraulic machine and a wheel loader, for example, that both of those machines having equivalent horsepower and horsepower to the cutting edge. The hydraulic machine is going to be a more aggressive digger. So poor blasted material that doesn't fragment well, that narrower edge is going to give you a lot greater power to break through that tough digging than the wheel loader, which has that 222 or 245 inch edge, which I'm taking that same amount of horsepower and spreading it out over that big edge. So it's not going to be near as aggressive as our hydraulic backhoe or our hydraulic front shovel. So if you think about bucket fill factors, which is a key to anything, is that we always want to be coming out with this 90 to 105% bucket fill factor. It's important that we look at the tool that we're going to be using. Think about a wheel loader and a rope shovel as a loading tool. Okay, so it's designed to have the material fragmented very well so that it can go in and in a nice easy movement, usually in the 30-35 second cycle range, can come out with that 100+% fill. The hydraulic excavator, we still require the same fills, but they're going to be much more aggressive. You're going to get those fills, but you're going to take that power and put it across that small edge.
Okay. And in general, we're always recommending that the investment be made on the blasting side of things wherever possible, because obviously the better fragmented the material is, that's ideal for all of the loading tools. So when in doubt, be focusing on that and putting, where you can, the investment into the blasting and the drilling so that it's not offsetting and raising your cost on the loading tool side.
Great point too, and you know, as you said, is what you will notice up front is that I'm not getting the fill in my bucket due to poor blasting. The thing that you won't realize for a couple of years is that I've probably taken 20 or 30% out of the life of that machine. You know, you look at a rope shovel, for example, those machines are designed to run 120 plus thousand hours. Mm-hmm. They require a long mine life, but they run a long time. You look at like a hydraulic machine, whether it be the wheel loader or the hydraulic shovels, machine life for them can be anywhere from 40 to 60, we've seen some as high as 70,000 hours. But they're running in well-blasted material. You take a machine and put it in poorly blasted material that doesn't fragment, the machine's got to work much harder, you're taking life out of the machine.
Yeah. All right, let's switch gears for a second and let's talk pass match with trucks, either with your existing fleet or your planned fleet. How does that factor in? That's a very important piece of this.
Well, I think you can go through our literature and we know very well what ideal pass match is. Today, we really like to see, with the rope shovel, we like to see 3 to 4 pass. That's the ideal range where we're going to achieve our lowest cost per ton. With our hydraulic machines, we like to be anywhere between 4 to 5 pass. Once you start getting to 6, 7, and 8 pass, it's really starting to add a lot of cost. So when we start looking at how we're configuring our trucks and we're configuring our machines with our buckets and our bodies, we need to make sure that these things match up perfectly. So this goes all the way back to blasting. We need to make sure that we blast it well so that we're coming out with 100% bucket fill every time. That way we know we're going to achieve that 4 pass match. Remember, if you go back to get one more pass, it's probably going to cost you 30 seconds. So you add that up by, you know, maybe 30 or 40 trucks an hour, and by the end of the day, you've probably given up maybe 10 or 15 trucks. So it's very important that we work with them to make sure we understand material density, and then we start looking at bucket size and truck tray size or body size.
And I think really the takeaway here in all of this discussion is that you can't just look at 1 or 2 factors and base your recommendation on that. You can't look at having an electrified mine and a long mine life, which are keys to putting in an electric rope shovel, but you can't stop there. You need to look at as many factors as possible before you go ahead and make a recommendation.
Absolutely, and you know, we talked about floor conditions, but now we need to talk about face height. For example, you know, we were fortunate enough today to have all the machines sitting right behind us here, and that doesn't happen very often. But if you look at the shiv on the top of that 7495, that should be the bench height for an electric rope shovel. Mm-hmm. But obviously you can't put a backhoe up there and expect him to be productive because we're going to have to set the trucks on top. Obviously it wouldn't be safe to put a hydraulic front shovel in that face because we can't control the top, so it becomes a safety risk. Mm-hmm. So the mine plan is going to also help us determine what tool is going to do the best. If you have a lot of pockets that we need to move to throughout the day, a wheel loader would probably be ideal because it's a very mobile machine. Mm-hmm. If you're working in a gold mine, for example, and you have a lot of high-grade pockets and you need to blend high-grade and low-grade and things like that, a hydraulic front shovel is best because we can reach up into the face and we can pluck out these pockets, or the same with a backhoe. So there's a lot of advantage to those machines as well. So yeah, you have to understand face height. We have to understand bench height, that we're running backhoes, and you know, all those things become very critical. Like a backhoe, for example, being 2 foot too high can cause us a lot of pain rather than being on grade or maybe even being just a little bit lower. But anything that impacts bucket fill factor and cycle times is going to have a huge negative impact on our cost per ton.
All right, well, as you mentioned, we've got the machines here behind us. It's a pretty unique situation, so why don't we put on our safety gear, we'll head down there and we'll talk about each machine and what are really the most favorable conditions for operating each of those machines.
Great, sounds great.
All right.